Hello everyone. This lecture is on conditional probability. In previous videos, we have already covered probability and set theory. We will be leveraging these two concepts while building our understanding on conditional probability. Make sure that you have already watched those two videos. If A and B are any two events, then P A by B, which is probability of event A happening, given that event B has already happened, is given by the ratio of PA intersection B divided by PB. This simply can be written in terms of number of events as well. Let's take an example here. Say I want to predict that what is the probability that it will rain today. Now, if I take a random event, I might say that there are only two outcomes, that either it will rain today or it will not. So the probability seems to be 1 by 2. Now, if I have some reason, or say yesterday it rained, and this yesterday it rained is event B. So I know that yesterday it rained. Now what is the probability that event A will happen? Now it can be more likely or less likely, but PA by B can be different than PA. So summarizing what I just said, PA by B is the probability of event A happening, given that B has already happened. This number is given by the ratio of probability of both A and B happening divided by probability of event B happening. Next, we will come to Bayes' theorem. This is one of the most important theorem in long language of probabilities. We will simply demonstrate you Bayes' theorem through an example. We will not go into statistical derivation of Bayes' theorem. Let's see what this example tells you. We have a grid here which is based on a population of 700 people. Out of these 700, there are 300 males and 400 females. Out of these 700 again, there are 400 smokers and 300 non-smokers. You have a distribution of male smokers, female smoker, etc., which can be found in this grid. Now, there are certain numbers which you can directly find. If I choose a person at random, what is the probability that I will choose a male person? The probability will be 300 by 700. Probability that I choose a female will again be 400 divided by 700. Now, coming to conditional probabilities, if I know that I am choosing a male person, what is the probability that I choose a smoker? Now here, the total population of male is 300 and the smoker is 250. So PS by M is 250 by 300. Similarly, PS by F is 150 by 400. Now, PS can be directly calculated from this table, which is total smokers are 400 and total population is 700. So probability of choosing a smoker at random out of these 700 people is 400 by 700. Now, Bayes' theorem is a way of calculating probabilities. If I know all these numbers which are in black, I can calculate this number in red. Let's use Bayes' theorem to do this. PS is given by probability of S intersection M plus probability of S intersection F. M is choosing a male and F is choosing a female. Note that if I sum up all males and females, I will get the total population. So Bayes' theorem says that I can predict, or I can come to this number, which is probability of choosing a smoker, by summing up P of S intersection M plus P of S intersection F. S intersection M can again be given by PS by M into PM. This comes from the formula which we just saw in conditional probabilities. And PS intersection F can be given by PS by F into PF. If you substitute all the numbers, you will get the same number which you get here. So Bayes' theorem is a way of calculating probabilities. Sometimes you will not have the freedom to calculate this number directly, and hence you will be using Bayes' theorem to calculate this number. Let's just generalize this Bayes theorem. We say that P of event Bk happening, given that A has already happened, is equal to P of A intersection Bk, which can be given by this formula as well from the conditional probabilities, divided by P of A. And P of A can be given as a summation of P of A by Bi into P of Bi, I to n. And this is what we just read from Bayes theorem. So this is a generalization of Bayes theorem, and this formula will be very useful when you solve some of the case studies which are known problems of probability, which are classic problems where you have some intuitive feeling and the probability tells you that this intuition is actually wrong. Let's take some examples just to solidify what we just read. Say that P of event A happening is 0.3, P of B is 0.6, and P of B by A, which is event B happening given that A has already happened, is 0.4. You have to find these three numbers. You can pause the video here and you can find these values. Here's the first one. So P A intersection B can be directly leveraged from the conditional probability formula, and you will see that it will come out to be 0.12. P A union B can directly be leveraged from the set theory concept, and A union B can be said as sum of A plus B minus A intersection B. A intersection B probability has already been found in the last bit, which is 0.12, and you come up with A union B is equal to 0.78. Lastly, coming to P A by B. For A by B, you need P A intersection B, which you have found in the first bit, which is 0.12, divided by P B, which is 0.6. Finally, you come up with the probability of A divided by B, which is 0.2. As you see that this number is significantly different when you compare it with A. P A is the probability of event A happening. P A by B is the probability of A happening, given that B has already happened. So, having said that, we here complete all the concepts in probability. Next, we will be solving some of the case studies which will be very interesting, and these are classic examples which are quoted when we study about probabilities. Thank you for watching this video.